Well, hello everyone. This is KP, the Math G. Delighted to be able to present another lesson dealing with relative and absolute maximums and minimums. I was doing a little studying myself. The KP, the Math G studies too also, but just really to refresh my memory on certain things. I did find out some things though, and I want to share them with you. Relative is sometimes used, maybe your instructor or professor uses the word local instead of relative, but relative and local are the same thing. Absolute, also another word with that is global, and I noticed I was looking this up, and I noticed that absolute and global are synonymous to each other. So if you hear one or the other, you know that's it. Okay. Now, just a real quick view. Well, let's call this function g somewhere. Okay, g. All right. We have an absolute max right here at x equals, and we got to remember we are looking at the closed interval from -4 to 2. Got to remember that. If it's on the open interval, well, we don't even consider the endpoints. And that's another thing too, is that when we're dealing with absolute extrema, especially if you're in AP calculus, you will have to deal with the endpoints as well, especially if you see that closed interval. You have to remember you have to check the endpoints as well. Unlike me, who did not check the endpoints one time before, and I realized that, oh yeah, this is the extreme value theorem. Yes, I have to check the endpoints as well. Alright, now this one here is it's an absolute. It's an absolute min though. Okay? It's also a local min, even though it's absolute. It's considered local in that -2 and 1 are what we call critical numbers. Some people say critical points. Okay, critical values are actually critical points. Alright, so they're within the closed interval from -4, or actually within the open interval from -4 to 2. These are called critical numbers. Okay, but anyway, it's an absolute min. Okay, this is a maximum, but it's not an absolute max. We might say then in this case it's either a local or a relative max. Alright. This point here is interesting because it's an endpoint, but since it's on the closed interval of a continuous function g, alright, and by the way differentiable for that matter in all places, then this point right here is considered. Now, I think I read one textbook where they say the endpoints are not considered local or relative maxes and mins, but I do know in the general sector that the book that I read is probably outdated too. So, but now in what I've been reading here recently, this is considered a local or relative max. So yeah, min rather. Now you can't take the derivative, but still we're talking about on the closed interval. It is a relative min. I was just reading a book not too long ago that they don't consider these points here. They had a little point called point B, and they didn't say anything about that point, whether it was relative or not, but I got to looking it up on Google and other places, and Yeah, they consider that a relative min. All right, so that's why I study this. So I can know this. Some people call this a local. Still, it's local because it's in the closed interval, and that's what needs to be emphasized here. Also notice that where you have this relative, or whether it's relative or absolute, either one, that if it's a minimum, that the graph will be decreasing. This point right here, the slope m is 0. M is equal to 0 here. M is equal to 0 here. Alright? But this is a minimum because the signs change from negative to positive. This is a maximum because this changes from positive to negative. G is increasing to the left of the slope, and G is decreasing to the right of 1, of x equals 1. Alright, so that's just a very quick idea here. Alright, now when we turn back over, and I'm looking at really this question, this is, I want to say the third time. I want to say this is the third time we're looking at this, and maybe the last time. I don't know. I may do one more video on this because there's so many things that can come out of this one particular question, and it's the 2004 question number 5, 2004 free response question. And this one does ask for let's see. It says this. It says find the absolute. I don't know where in the world I want to write this, but anyway, maybe I can put it here. Find the absolute, and in this particular case, minimum. Okay, minimum value of G, and that's important that we understand that we do find the absolute minimum value of G. This function right here is G. We take, but if we take, actually this function is F, but that's only if we take the derivative of G that we get F. Okay, so we're going to use this function right here, since it says the value of G, we've got to use G to find our maxes and minimums. Okay, and that is the key to understanding this problem. Okay, is that when it says the absolute minimum value of G, well, we've got to look at G right here. Everything that we find has got to come from G. Now, we've got to look at this graph to see if there is a we know we need to look at the endpoints, so we need to look at -5, and we need to look at 4. So we know that by the extreme value theorem, that's what I was just talking about a while ago, that we have to look at -5 and x is equal to +4. But is there anything in between here? And it says minimum, so we're looking at the absolute min. And you got to pay attention to that, because you may accidentally find an absolute max in this also, which we're going to do anyway, but I just want you to be aware that I want to do what they're asking for. We're going to do the absolute min. Like on the other side now, we did have an absolute min, and it was within, it was not one of the endpoints. We did have an absolute max, it was one of the endpoints. So we have to see where all this is. Now, okay, let's see. Min. A min is like this. This would be a min. As a matter of fact, this is an absolute min. Okay, but because, I mean, it's the absolute lowest point on this graph here. Okay, that's what that means. Okay, so what's happening here? All right, let's call this, say, ELF. ELF is decreasing to the left. The slope M is equal to 0, and it's increasing to the right of whatever this number is. Let's call it, say, A. All right, point A. All right, so we got to find something where the graph is decreasing and the graph is increasing. Now we got to remember, from the last video, we said that it's decreasing. This is decreasing if any part of the graph is below the x-axis. You're comparing everything to the x-axis, relative to the x-axis. This is below the x-axis. Okay, so this would be negative. This is below the x-axis. This would be negative. Alright, right here, the slope at -4, the slope is 0. This is above. It looks like that fits that right there. So, okay, so we're looking at x equals -5. We're looking at x equals 4. And we're looking at x equals -4, which, by the way, is considered to be a critical point. Why not look at this one? Well, because we can't look at this one because we're looking for the absolute min. This is positive to the left of this and negative below here. This is a max. Positive going up, increasing, negative going down. We can't check 3. And we can't check this because the signs do not change. Even though we do have a slope of 0, the signs do not change. Okay, because, well, this is positive. It's above the x-axis at all times, except for when it does cross. It doesn't actually cross. It touches the x-axis there. Okay, I say cross. It's got to go through it. All right, so this would be a candidate for a max, but we're only looking for the min. All right, we got to use G because it says value of G there. Okay, so let's use this one. We already have the numbers up here, and from this is from a couple of videos ago. I've already predetermined, and I can show you again. I'm going to work in this area. I'm going to show you again why this is -1 here and this is 1, and 9/2 here, 2 minus pi over 2, 1/2, -1/2. I did show that in a previous video. I may try to show it again if we have time. But we do at least already have the numbers. And let me just go over something. Let's go over a triangle, for example. This is 1 unit, and this is 2 units down. So 1 times 2, and then divided by 2. Remember, the area of a triangle is the base times the height divided by 2. So 2 over 2 is 1. And I know since it's down here it should be -1, but I'm going to show you why it's +1 in just a moment. Okay, because of this being defined like this. Okay, so let's just go ahead and since we already need to deal with -5 anyway, we are looking at this interval. Alright, so let's see. We're saying then that from -3 to -5, L at t dt. L at t dt. This is just a function here, but notice that here on the number line, -3 is to the -5 is to the left of -3 as it should be, but it's further over. On the definite integral though, we want the larger number on top and the smaller one on the bottom. When we change that from -5 to -3, we have to make this negative. That's a rule. That's just a calculus rule. When you change the order here, you change the sign here. Okay. Now, I know, and we just found this answer, to be equal to 1. Right there. It is 1. Well, it's actually negative 1. Okay, because it's below the x-axis, it's negative 1. But the negative in front makes this negative 1. Okay, this is actually negative 1. But since this is to the left of negative 3 here, and we had to flip this around, we have to account for this negative sign right here. So even though this is technically negative 1, the negative 1 makes this equal to positive 1. So this here, we know then, is, we're just going to put a colon here, and we're going to say, well, let's see, g at negative, g at, oh, okay, that is, oh, but we're also going to 3 also. But we got to take this into account also. We got to, this is from negative 5 to negative 4 here, okay? But we're actually going from negative 5 to negative 3. So I still got to look at this area as well, okay? So if we're looking at everything, I'm looking at the area of this triangle and the area of this triangle. I was thinking about negative 5 to negative 4 is negative 1, okay? So g at negative 5, what's that equal to? Well, we're going to find that out in just a minute. We got this portion right here. It is 1. And if we go from negative 4 to 3, this is also 1, because 1 times 2 is 2. Alright, and 1 times 2 divided by 2 is 2 over 2. And that's 1, but remember, that changes also. Let's see, well, this is from, alright, right there. Okay, okay, right there. I can do that. I'm just looking at this part right here. But we need to understand that we're also looking at this part from negative 3 to negative 4 also. And that is going to include all of it, okay? Alright, so let's see, f at t dt, and we found that to be equal to 1, but since we had to exchange this order like this, okay, that makes it negative 1, okay? So whatever the answer was, this negative is right here, and that makes it negative 1. Okay, so this is 1, this is negative 1, and when you add these two areas together, we're looking at displacement area. So when we look at this area together, this is 1 plus negative 1, which is 0. So g at negative 5 is actually 0. And I just want to emphasize one thing. Whether you fully understand this or not. Okay, let me erase where I can turn around and talk to you. I hate talking to the board. And I know I'm just talking to the camera, but I feel like I'm talking to you because you're the one watching, so you can see what's going on. If you have two triangles of the same area like this, no matter whether you understand this to be 1 or negative 1 or what, and you're looking at this region from negative 5 to 3 to negative 3, you're looking at this triangle and this triangle, and no matter whether you understand whether this is 1 or negative 1 or this is 1 or negative 1, the displacement area is what you're looking for. So 1 plus negative 1 equals 0. And that's what you need to understand. You're looking at this area here plus this area here. This area plus this area is equal to 0. Alright. Now, f at 4. Now, we're looking at from -3, according to our definition, we got to put our -3 here, to 4. F at t dt. Alright? That's what we're looking at. We got to put the -3 down because that's part of this g here. We're plugging in place of x, we're looking at 4 right here. So we're saying that g at 4 is going to be equal to something in just a moment. Now I want to show you something, so that we won't be going into a whole bunch of stuff here. We've already found this to be 9/2. Alright, and I could show you how this is a trapezoid. This height is 2 and this height is 1. So what we have is 2 plus 1. Alright, and then this distance, this is the height of it. Actually, it's laying sideways. So base 1, base 2, and then the height is 1, 2, 3. So times 3, and of course, divided by 2. So this is 3 times 3 divided by 2, which is equal to 9/2. So we're looking at this area here, plus we're looking at this area here, and I've already found that. If you want to look that up in another video, you can, but this answer is 2 minus pi/2. We're going all the way to 4. This is 1/2. This is -1/2. And I found these from another. This is easy to find anyway. Alright. And that, if I have time, I might just go ahead and find this, but right now we're just kind of, my video camera, it might run out of time on me, so I'm trying to keep that in mind. So this right here from -3 to 0 is 9/2. Alright, from 0 to, we're looking at from 0 to, we're going all the way to 4, aren't we? Well, from 0 to 2, we know that is 2 plus, or minus rather, 2 minus pi/2. And we know this is plus 1/2, and we know this is minus 1/2. Okay? Alright. This right here is 0. So if we add all of this up, this is 9/2. And remember how I did this? 2 times 2 is 4. So plus 4/2. 4/2 is 2. Minus pi/2. 4 plus 9 is 13. So 13/2 minus pi/2. Or you can just say 13 minus pi/2. Alright. Remember, these, we're going all the way to 4. These two cancel each other out, or we say we add up to 0. This is this part right here, and this is this part right here. So we added it up all the way over. Okay. So that's what this is. So wow, I don't have a place to put that, all of that. So let's put this somewhere over here. I'll tell you what, I'm blessed to have this board, but sometimes my board space gets limited. Of course, this graph takes up a lot of my board space. Alright, so let's put down, alright, we're just going to have to say g at 4 somewhere else. Alright, x equals 4. Alright, we'll just leave it here in this corner. X equals 4, that means that g at 4 equals. Alright. Certainly I know that pi is 3.14, so this is a little bit less than 10, but if this were 10, this is 10/2, which is 5. Okay, but that's a little bit less than that because, well, anyway, pi is 3.14. Okay, so this is 9 point something over 2, which is greater than 0. Alright, greater than 0, isn't it? Okay, we think of pi as just even 3. 13 minus 3 is 10, and 10/2 is 5, and 5 is certainly greater than 0. Alright, so that's greater than 0. We're looking for, this is equal to 0, so far x equals at negative 5 is less than this one, okay? Now let's try negative 4. Well, let's see, negative 4 right here. Okay, so we're going from negative 3 to negative 4, L at t dt. We found that area to actually be equal to 1. Okay, but this is not in the right way of writing it. We don't say that, we got to change that order. Okay, negative 3 up here. The bigger number goes on top, the smaller number goes on the bottom. But when you change that, that negative has to pop out there. And that's what I'm trying to say. Alright, so this is equal to 1, but it's actually equal to negative 1. Alright, the negative sign goes right there. So this is 1 technically, but since this is behind, anything behind this is going to be the opposite sign. Anything in front of negative 3 is going to be that sign. Okay, so kind of keep that in mind. This is the way they defined it in 2004. Alright, and might have used this later on, but a different number maybe, I don't know, but still, that's the idea. Alright, so this is actually negative 1. So G at negative 4 is negative 1. Now we're looking for the absolute minimum. We're looking for the smallest G. Okay? 0, we're comparing 0, negative 1, and 13 minus pi over 2. Okay? And so I already know this is greater than 0. We know this is positive. We know this is 0, but now this is the lowest one because this is lower than any of them. It's actually negative. So this is the only negative one we have. So G at negative 4 is the absolute minimum. And that's actually what they asked for here. And because G at negative 4, you have to show that right here. Just show that work right here, okay? In the box that you're required to show it in. Okay. Now, if they ask for an absolute max, then, okay, max, M-A-X. Alright, then this would be the absolute max. This is greater than 0. Even if we say pi is equal to 3, which is not, it's 3.14, still 13 minus 5 is 13. 8 divided by, I don't know why, 3. 13 minus 3 is 10, and 10 over 2 is 5. Well, even if it is less than 5, 4 point something, okay? Still, that's greater than 0. That's 0, and this would be the absolute. So while this would be the absolute min, this is the absolute max. So it depends on the problem. But if they ask for the absolute min, which they did in this 2004 question, then we don't need to worry about the absolute max. All we need to worry about is the absolute min. You need to show your work, show that this is, and compare to 3. Compare to 3, that's what you need to do. You have to remember though, which I didn't do before, to check the endpoints, because we are looking at the extreme value theorem. And I think the question will say it in the closed interval. And it does. If you look at letter C right there, it does say closed interval right there. Okay? You see what I'm talking about? So be very careful that you understand that you've got to try the endpoints when they include both endpoints, when it's on the closed interval like that. Okay, I hope you can see that. Alright, now that's it. That's everything I need to show you about this. There is another question which I may do in another video that talks about what is it, concavity, point of inflection. Yeah, so we got to look for points, but we're not going to worry about that at this point. We can get exhausted enough doing this right here, can't we? Okay, I'm KP the Math G. Please remember, if you want to, you can subscribe. I am getting more and more subscribers, so please subscribe. Of course, you don't have to. This is just a learning tool with me. That's all I'm here for, is to help you learn. Whether I get a bunch of subscribers or not, it does help if I do, but you don't have to subscribe. If you want to make a comment, please feel free to make a comment. And so, good or bad, I'll take, I'll take that, because I'm here to get better. Okay, and I always say that if you're going to say there's a better way, your better way needs to be correct. Okay, and so just please let me know where I can do better if there is a better way to do this. But we can also always say, good job, great job, KP the Math G. I always appreciate that. It does make me feel pretty good. Okay, I'm not here for compliments, though. I'm just here to help you. That's my main goal, is to help you get better and better. And I get better and better at this too. The more I do it, the better I get. Okay, well, KP the Math G signing off. Have a great day.